In this nugget, we will be looking at redox reactions. A redox reaction is one where both reduction and oxidation take place at the same time. Reduction and oxidation can be described as either the gain or loss of oxygen or electrons. Let's look at the oxygen description first. Oxidation is the gain of oxygen. Here we can see that the iron gains oxygen to become iron oxide. It has been oxidized. So this is an example of oxidation because oxygen has been added. Reduction is the loss of oxygen. And now we can see that mercury loses oxygen to become mercury metal. It has been reduced. So this is an example of reduction because oxygen has been removed. Now let's move on to a description that involves electrons. Remember, in this case, oxidation is the loss of electrons. This can be represented in an ionic half equation. These types of equations focus on just one reacting species and the electron movement associated with it in a particular chemical reaction. Here we can see that the zinc metal at the start loses 2 electrons. It is therefore oxidized, and this is then oxidation. Reduction, however, is the gain of electrons, and in this case, hydrogen ions gain electrons to become hydrogen gas. The ions are reduced, and so this is reduction. When describing oxidation and reduction as the gain or loss of electrons, we can use the mnemonic or acronym oil rig. This helps us remember which way round each of the descriptions should go. If we take our 2 definitions of oxidation and reduction, use the first letters from each, they spell out the word oil rig. Oxidation is loss. Reduction is gain of electrons. A good example of a redox reaction is the thermite reaction between aluminium and iron oxide. This is a displacement reaction which releases enough heat to melt the iron that is produced during the reaction. As a result, it can be used in industry to weld railway tracks together. This is a great example of a redox reaction because it demonstrates both types of oxidation and reduction. Let's look at the thermite reaction firstly in terms of oxygen. We can see that the aluminium is not bonded to oxygen at the start, but it is at the end. So it has gained oxygen. It has been oxidized. This shows us oxidation. The opposite is happening to the iron, however. It starts with oxygen bonded to it and loses this oxygen to become iron during the reaction. It is therefore reduced, and this shows reduction. Now let's look at thermite in terms of electron movement. This reaction can be broken down into separate ionic half equations. Firstly, each aluminium atom loses 3 electrons to become an aluminium ion with a 3+ charge. This represents oxidation because the aluminium has lost electrons. Each iron 3+ ion at the start of the reaction gains 3 electrons to become iron metal. Since it gains electrons, this is therefore reduction. Remember oil rig. Oxidation is loss, reduction is gain of electrons. To summarize, a redox reaction is one in which both reduction and oxidation take place. Oxidation can be described as the gain of oxygen or the loss of electrons. Reduction can be described as the loss of oxygen or the gain of electrons. The acronym oil rig can be used to help remember the correct way around. Oxidation is loss of electrons. Reduction is gain of electrons. Keywords. Reduction, when a substance loses oxygen or gains electrons. Oxidation, when a substance gains oxygen or loses electrons. Redox, a chemical reaction in which both reduction and oxidation take place. Mnemonic, a word or short sentence to aid with remembering something. Ionic half equation, equation showing electron movement for a reacting species.